You know, that moment you step into a place, maybe a huge shopping mall, a sports arena, a sprawling corporate campus, even a hospital, and your phone signal just, it vanishes.
Oh, yeah. Or you see one bar, but nothing actually loads.
It's incredibly frustrating. And for the businesses running those places, it's more than just annoying. It's a critical problem.
Absolutely. I mean, modern buildings, they're built to be energy efficient,
Hmm.
right? Thick walls, special glass. Great for insulation, but terrible for cell signals.
Like a fortress against the outside network.
Exactly. So getting reliable, strong wireless inside is, well, it's a major headache today.
And it's way beyond just ensuring personal calls work now. Businesses need their own robust, secure, really fast connectivity for their operations.
For the machines, sensors, internal systems.
Right. So how do you handle that? Needing powerful internal connectivity, but also making sure everyone else, visitors, employees on their own phones, gets signal too.
Well, that's the challenge. And we found this really interesting document that takes a deep dive into potential solutions.
Specifically looking at this indoor connectivity problem.
Yeah, and it zeroes in on the potential synergy between two sort of distinct but complementary ideas,
Hmm.
private 5G networks and neutral host solutions.
Okay, synergy. Let's unpack this then. Our mission for this deep dive is to explore this document, figure out what these two things are on their own,
Uh,
see how the source says they can work together, and why this combination might be, well, really important going forward.
for everything from factories to schools, big public venues.
Exactly. And the source hints at some pretty big shifts already happening. It mentions a projected market size for private 5G.
Yeah, a massive $36 billion by 2030.
Wow. Okay.
When it suggests these solutions are actually changing the basic economics of providing good indoor connectivity.
36 billion. That definitely tells you how critical this is becoming. All right, let's jump in. The document starts by explaining private 5G. How does it define that?
So, based on the source, it's a dedicated wireless system using 5G tech, but it's built and managed specifically for an organization.
Like a business or a
Same
university?
city, yeah. The key word is dedicated.
Okay, so dedicated. That's the main difference from just using your regular cell service, like the public network.
Exactly. Instead of relying on the public mobile network operators, the MNOs, your Verizons, AT&Ts, T-Mobiles, the private network is tailored.
Yeah.
It's controlled by the organization itself.
So they get the high-speed, low-latency, secure connection they need for their specific stuff.
Precisely. They have complete control over their network resources, their data.
The infrastructure is theirs.
Right. They manage it all without depending on the public MNOs for their core critical functions.
Okay, that makes a lot of sense, especially for places with sensitive data or systems that just cannot go down.
Uh-huh.
So why are businesses so interested in this? Why build their own 5G network instead of, say, just using advanced Wi-Fi or the public network? What benefits does the source really highlight?
Well, the document lists several really compelling reasons. First, performance. Private 5G gives you that ultra-low latency, essential for real-time operations, like automated systems needing instant responses.
Millisecond stuff.
Right. Plus high bandwidth, which you need for connecting tons of IoT devices or running real-time AI applications. And enhanced reliability. Fewer network interruptions that can mess up operations.
So faster, more reliable, more responsive, and tuned just for them.
Exactly. Then there's security, enhanced security.
How so?
Because the infrastructure is dedicated, it isolates their sensitive operational data. Less exposure.
Right, it's not mixing with public traffic in the same way.
And they can tailor their security measures. The force specifically mentions things like SIM-based authentication, strong encryption, comparing it favorably to, say, standard Wi-Fi in that regard.
That security layer sounds critical, especially with all the connected industrial machines or patient data in hospitals.
It really is. The third benefit mentioned is customization and scalability. You can optimize the network for very specific jobs within that, building a smart factory floor, a connected operating room, a busy airport tarmac. And it's designed to scale up easily if needs change.
Flexible for the future.
Yeah. And finally, cost efficiency.
Okay, this one's interesting. How is building your own network cost efficient?
Oh, there's an upfront investment, obviously, but the source argues it reduces dependency on paying for public network data usage for operations, which cuts down recurring costs.
Okay, lower OpEx over time.
Right. And maybe more importantly, it lowers operational downtime because it's more reliable. And it boosts productivity. All that adds up to significant savings in the total cost of ownership.
TCO. So the initial spend, the CapEx, plus the ongoing running costs, the OpEx, that whole picture is becoming more attractive.
That's exactly what the document points to. This reduction in TCO is a major driver. It lists all sorts of places interested: cities, public safety, airports, mines, schools, hospitals.
A really wide range.
Yeah, and it notes that many of these places still rely mostly on Wi-Fi or public networks today.
Okay, so that's private 5G. Dedicated, controlled, high-performance connectivity for the organization itself. What about the other piece? Indoor neutral host solutions. What problem do they solve?
They tackle that first problem we mentioned, getting the public cell signals into the building effectively.
For you and me using our regular phones.
Right. Dealing with that signal blocking from the building materials.
The attenuation.
Exactly. So
Yeah.
a neutral host system, as the source describes it, allows wireless infrastructure inside a building to be shared.
Shared by the different cell carriers.
Yes, by multiple mobile network operators, the MNOs.
Yeah.
So instead of, say, AT&T, Verizon, and T-Mobile, each having to put in their own separate antennas and gear inside a stadium,
Which sounds incredibly expensive and complicated.
a neutral host provides a single infrastructure layer, one set of antennas, maybe one set of electronics, that all of them can plug into and use to broadcast their signal.
Ah,
The source mentions neutral DAS as an example. DAS is a distributed antenna system. Think of it like a central hub, taking signals from different carriers and distributing them through antennas spread around the building.
got it. So the goal is, one, make sure everyone inside gets signal from their own carrier,
Wow.
and two, cut the carrier's costs because they don't each need to build out a full system in that venue.
Exactly. It's efficient for the MNOs, and it means seamless public coverage for visitors, employees, everyone inside, regardless of their carrier.
Okay, so private 5G for the building's own stuff, neutral hosts for shared public access. They sound quite different. How does the source say they work together? Where's the synergy?
Right. This is where it gets really interesting, kind of the core idea in the document. The key is that while they do different main jobs, they address related needs, and crucially, they can coexist. They can complement each other in the same building.
So the building owner gets their private network humming for their operations,
Yep.
and everyone else gets good public cell service through their normal carrier, all at the same time.
That's the idea. The private 5G network focuses on the internal, often mission-critical stuff for the venue owner or the enterprise,
Like managing robots in a warehouse.
where critical hospital applications, connecting their own security cameras, IoT sensors, that kind of thing.
And the neutral host part handles.
The public network access for everybody else.
Sure.
Employees using their personal phones, visitors, customers.
Yeah.
They connect through the shared neutral host gear using their regular carrier service.
Okay, a dual setup. What are the benefits of doing it this way, combining them?
The document points to several upsides. It creates a more unified communication setup indoors.
Right.
You get the dedicated performance and customization of private 5G, plus the cost efficiency and wide reach of the shared neutral host.
Best of both worlds, potentially.
Yeah, and this dual approach really enhances the overall user experience.
Mm.
You get consistent indoor coverage for all kinds of connectivity needs, both private and public.
And the source mentions supporting diverse business models. How does the neutral host part help the enterprise running the private network? Is there a benefit there too?
Yeah, this is quite clever. The source explains the enterprise can actually leverage that shared neutral host infrastructure to sort of offload some connectivity needs.
Offload.
Meaning they might not need to build out their private 5G network to cover absolutely every square inch or every single use case. Some basic access, maybe for less critical internal apps or even just general employee device use.
Could potentially run over the shared system.
Potentially, yes.
Yeah.
Or at least the presence of the robust neutral host infrastructure might reduce the demand placed on the private network for non-critical things. This helps minimize the CapEx and OpEx for the private network's expansion.
So it's about optimizing resources, using the shared layer where it makes sense to ease the burden on the dedicated private one.
Exactly. The document then gets into the practical side, like how you actually build this out. It compares different ways of doing it, like using DAS versus small cells.
Right. We mentioned DAS for neutral hosts. What about small cells? How does the source compare those two approaches?
Okay, so it presents them as different tools for the job of indoor coverage. DAS, distributed antenna systems, as we said, are pretty established, often involve a lot of cabling.
Running wires everywhere.
Yeah, piping signals from a central point out to antennas spread through the building. The document notes they often need significant coordination with the carriers and are mainly about amplifying existing signals.
Okay. And small cells. Are they different? Maybe newer?
The source suggests small cells offer some real advantages, especially for modern networks like 5G in terms of flexibility and efficiency.
How so?
They're described as more self-contained units, often simpler to install, sometimes almost plug and play. They provide localized coverage and capacity right where you need it.
So maybe less invasive cabling needed compared to a big DAS.
Potentially, yeah. Their smaller size can mean less disruption. The source points to potentially lower labor and installation costs, especially if the cabling is simpler, and maybe lower upfront costs too, particularly for smaller projects or initial rollouts.
Easier to deploy incrementally.
Yeah, more scalable in that sense. Offers more flexibility.
And for 5G performance.
The document says small cells are built to support advanced 5G features. Things like carrier aggregation, combining frequency bands for speed, and dynamic spectrum sharing.
So they can deliver good speeds.
Competitive speeds and user experiences, yes. A key difference mentioned is they can often support multiple carriers independently within the small cell unit itself, whereas traditional passive DAS needs more direct integration work with each carrier signal source.
Ah,
So the source kind of positions small cells as more adaptable, maybe more future-proof, especially for evolving 5G tech.
it sounds like the source sees them as a more modern, modular way to go, particularly for scaling 5G indoors. And wasn't there a really striking point in the document about the cost of private 5G in this context?
Yes, absolutely. This is highlighted as a critical development. The source explicitly states that the total cost of ownership, the TCO, for private 5G networks has dropped
Dropped how much?
down to the level of Wi-Fi.
Wow. Okay. As cost-effective as Wi-Fi, that really does feel like a potential game changer. Does the source explain why that's happening or what it unlocks? I mean, if dedicated high-performance cellular isn't vastly pricier than standard Wi-Fi anymore, what becomes possible?
It doesn't detail the exact tech reasons for the cost drop beyond, general tech advancement,
Right.
but it presents that TCO parity as a major catalyst.
Right.
It suggests this cost evolution is fundamentally changing the discussion. It makes private networks feasible where maybe only Wi-Fi was considered affordable before.
So that affordability plus the security and performance benefits of 5G.
Opens the door for more businesses to implement things like real-time automation, widespread IoT, advanced analytics, stuff they maybe couldn't justify the cost for previously.
That certainly helps explain that $36 billion market projection. Okay, so if an organization decides, yes, we want this, how do they integrate the private 5G part? Especially if they already have some kind of indoor system for public cell service.
The source lays out two main scenarios. First, if an enterprise is starting from scratch, no existing indoor system for public carriers.
A clean slate.
Right. They can build the neutral host capability right into their new private 5G deployment from day one. The source says potentially at no additional cost, essentially designing the system to handle both from the outset.
Bill it right the first time for both private and public needs. Makes sense.
Exactly. The second scenario is for places that already have neutral host infrastructure, like an existing DAS system that's mainly serving the public carriers.
Okay, they have the shared system running.
In that case, they can implement the private 5G network by integrating it with that existing DAS.
How does that work? Do they just plug it in
Yeah.
somehow?
Kind of, yeah. The source explains the private 5G solution basically acts as another signal source, an additional radio frequency or RF signal that gets fed into the existing DAS equipment, like the access unit.
That's fascinating. So the existing pipes, the DAS designed for public carrier signals, can now also carry the enterprise's own dedicated private 5G signal,
Yes, precisely. So they can leverage what they already have installed.
which avoids ripping everything out and starting over.
Right. It reduces deployment costs, simplifies the upgrade process, and speeds things up because a lot of the physical infrastructure, the cabling, is already there.
So they can add this powerful private layer while keeping the existing public service running smoothly.
Exactly. Maintaining seamless operations and ensuring that backward compatibility. It's a practical way to evolve what's already there.
We've talked a lot about the enterprise, the building owner, and the carriers. But the source mentioned other winners here too, right? Like the venue owner specifically, and maybe tower operators.
That's right. For the venue owner, the document really emphasizes the benefit of gaining control over their own operational data.
How so?
They can connect all their internal stuff, IoT sensors, security cameras, building management systems using their private 5G network. This ensures their critical operational data stays within their control on their network.
And isn't necessarily traveling the same paths as all the public carrier traffic.
Exactly. They get that high-performance, private connection for their needs without messing with the neutrality of the shared infrastructure that the public MNOs are using.
That separation seems really important for security and data privacy.
It is. And then for the tower operator, the company that might actually own or manage the physical gear inside the building, like the DAS or the small cells.
The infrastructure provider.
Right. For them, this synergy is presented as a big plus. A neutral host model that also supports private 5G means they're maximizing how much that infrastructure gets used.
More tenants on their system.
Exactly. They can lease capacity to multiple MNOs and to the building owner for their private network. This opens up new revenue streams, like offering private 5G as a managed service.
Okay.
It also helps the MNOs because they can lease capacity instead of building it all themselves, which lowers their costs. And for the tower operator, it helps them improve overall coverage, potentially even in tricky indoor or rural spots, and supports that huge growing demand from enterprises for reliable IoT connectivity.
So the infrastructure owner gets more revenue, better utilization, the carriers save money, the venue owner gets dedicated performance plus control over public access, and the end user, well, hopefully just gets reliable signal everywhere.
It really sounds like a win-win-win scenario
Yeah.
based on the framework in the source.
Yeah, a multifaceted benefit.
And the document also gives some context for why this is really taking off now. It mentions the regulatory side.
Ah, right, spectrum allocation.
Exactly. Things like CBRS spectrum in the U.S. and specific bands like N77 and N78 in parts of Europe, which have been specifically set aside to enable private networks.
That makes sense. Having dedicated airwaves helps. Although I think the source did mention maybe slower uptake in Europe initially. Something about cost perception.
Yes. It noted that as a potential challenge, a perception of high cost compared to Wi-Fi, maybe some complexity. But the document immediately follows that up by reinforcing the point we discussed, that the TCO of private 5G is coming down to that Wi-Fi level. And it stresses that the growing focus today on security and needing resilient, dedicated networks is driving the demand anyway, kind of overriding those earlier cost concerns.
So the need for secure, reliable, private connectivity is becoming paramount.
Exactly, which this kind of synergistic private 5G and neutral host system is perfectly set up to deliver.
Okay, so let's step back and wrap this up. This deep dive into the source material really shows us that this long-standing challenge, getting good, reliable wireless inside buildings, is being tackled head-on.
By combining these two powerful ideas, private 5G for the dedicated, secure needs of the organization,
And neutral host solutions for that shared, ubiquitous public cell access everyone expects.
and this synergy, this combination, lets organizations build this unified indoor wireless ecosystem. It delivers the custom performance and security they need for advanced stuff.
Alongside the seamless public coverage people want, and it's becoming more and more cost-effective to do it.
Right.
It's clear this isn't just some niche tech for giant factories anymore. It's really shaping the connectivity experience in the places you work, learn, shop, travel, even hospitals.
It enables everything from just getting decent cell service indoors to powering those hidden networks running automated systems and real-time data in our most complex environments.
Which brings us back to that really surprising point about cost, doesn't it?
It does. If highly secure, high-performance private cellular connectivity is truly becoming as accessible and affordable as Wi-Fi,
While also integrating smoothly with shared public access infrastructure.
it really makes you wonder. So here's a final thought based on the source for you to consider. How might this fundamental shift in cost and capability change the way we design, build, and ultimately use our buildings and public spaces in the years to come?